So today what we're going to be doing is we're going to be taking notes on scatter plots and lines of best fit. So it's kind of like two different topics here. The first one we're going to be covering is scatter plots. And what is a scatter plot? It is a graph that shows the relationship between two sets of data. And then we have a couple of different types of relationships. We've got our positive, where it's just very similar to slope. So this one here, you read it going from left to right. And if it's going in the up direction, like our first one here, then it's positive. If it's going in the down direction, then it's negative. And then sometimes there's no exact correlation there. It's just kind of all over the place. So that one would just be none. Then our next thing here, sometimes we can determine the type of relationship that would be most likely shown by the data. Our first one, if you have the size of a home versus the size of its lot, if you were to graph it out, it would look like this one here. It would look like there's no correlation at all. Whereas if you have number two, the number of passengers on a plane versus the number of suitcases, that one's going to be positive because the more passengers you have on your plane, the more suitcases there's going to be on the plane. So that is positive. Last one, number three, number of days into fall versus number of leaves on the tree. So I know we live in Florida. Not sure if anyone's from anywhere else, but typically in fall, the more days you go into that season of fall, there's less leaves on the tree. So that would be a negative correlation. This is the days into fall, and then the number of leaves on a tree. So at the very beginning of fall, there's the most leaves, and then closest to the end of fall, there's not a lot of leaves. So that would be a negative correlation. Okay, but we're from Florida. We pretty much just have like summer all year round, so it's kind of hard to imagine that. But up north, there are different seasons, I promise. Let's actually get to drawing some scatter plots. It says here, draw the scatter plot and identify the relationship shown. And we've got number 4. It says the number of hours a student studied for a test and their grade. I already kind of labeled the graph for you. We've got our hours down here and then our grade over here on the side. And then all we're going to be doing is really just like plotting the points. So we've got our first one. It's kind of like the point 3, 80. So you would come down here on the side, look for a 3, and then you would move on up to that 80, and you would draw your first dot. It's just like plotting points. So I did my first one. Then my next one is 590. So I go over to the 5, and I go up to 90, draw my dot. That one's done. And the next one is 2 and then 45. So I go down to 2, up to 45. And this one kind of falls in between the 40 and the 50. So just try your best. It's not going to be perfect. That one's done. Then we got 685. So 6, go up to 85, which is about here. That one's done. And then 895, 8. And then 95, which it's in between. And then we've got 155, 155, it falls in between. 2, and then 60. And then 7 and 100. And last one, 4 and 75. 4 and 75. Okay. So we were talking about the number of hours a student studied for a test and their grade. So we can see that if they only studied for 1 hour, their grade is going to be about here. But if they studied for 8 hours, their grade's a little bit better. You can see how their grade correlated. The more hours that they were studying, the higher that their grade was. So now we want to see what kind of relationship it is. If it's positive, negative, or none. Which one does it look like? The positive picture, we're going to look up here. Does it look like positive, negative, or none? Or you can even just kind of like draw a line that goes through that kind of fits it as best you can. And just like slope, you read it from left to right, like I said before. If it's going up, it's positive. If it's going down, it's negative. But if there's no correlation at all, there's just random dots everywhere, not even forming some sort of line, then that would just be none. So which one is this for number 4? Is it a positive, negative, or none? What kind of correlation is it? Positive, negative, or none? You can type it in the chat or you can turn your microphone on. For number 4, which one does it look like? Positive, negative, or none? Well, if we look at our examples here, here's our dots. They're kind of going in the upwards direction. So that's going to look most like our positive. So number 4 is positive, okay? Because they're kind of going that upwards direction. Let's go on to the next one. Number 5, it says the number of hours a person spent in the mall and the amount of money they spent. I already went through and put it onto the graph because I feel like you guys could do that. It's not too difficult. It's something that you've been doing for a long time, plotting points. So let's look at this one here. Here's all of our points. I can't really form it into a line, whether it's going like in the upwards direction like number 4. So go ahead and tell me number 5. Is this positive, negative, or none? I see someone typed in none, and that is correct. There is no correlation here. So depending on how many hours you spend on the mall, it doesn't really affect the amount of money that they spent. I'm not sure if you guys have ever been to the mall. I know sometimes you buy things, sometimes you don't. There's no real correlation with it. It's just kind of random. I mean, some people have shopping problems and they always buy things, but for the most part, average person, there's no correlation between that. So that's why it would just be none. And then we just have our visual there. Let's keep on going. Number 6, it says the percent of households in a city with a landline telephone, okay? So we've got our, so they told us the year, so I put that down here, and then our percent of homes with a landline. Not sure if you guys, if anyone even has those anymore, but it's the house phone that's like plugged into the house. But you probably don't really have those because you'll see here in just a second. Let's see, what kind of correlation is this? Positive, negative, or none? You read it from left to right. This one's going in the downwards direction. I see someone wrote negative, and that is correct. It is a negative correlation. So you can see in like 2004, there was, let's see here, you can even look here, 73% of homes had a landline, whereas like 2016, it was only 42%, okay? We're now in 2021. I'm pretty sure it's closer to 0 now. But because it is a negative correlation, that is an actual realistic picture to look at there, because the more current date that we're getting to, the less houses have, the less percentage of homes have a landline. Okay, number 7, it says the toll to drive on a section of highway each year since the toll began. I went ahead and put it on there for you, our years and our dollars, years and dollars. Here's all of our points plotted on there. Is this going to be a positive, negative, or none? Remember, you read it from left to right. If it goes up, it's positive, down is negative, and if it's all over the place, it would just be none. So what is number 7? Positive, negative, or none? You can see here for number 7, it's going from left to right. It's going in the upwards direction. So number 7 is positive. Okay. So we've kind of got just like the basic understanding of it with how to identify whether it's positive, negative, or none. Now let's get a little bit further with reading scatter plots. So we've got number 8 here. It says a company's stock price since it launched in 2006 is shown below. And then we've got our first question A. What is the approximate stock price in 2015? So let's just look at our graph. We have our stock price and we have our year. It's asking us, what is the approximate stock price in 2015? So we know we're going to be looking at 2015. So that's going to be about like here at this point. And we want to see what is going to be the approximate stock price. So let's just stay on this line here until we find a dot, and there's a dot right there. It's falling on 2015. So then you would just kind of drag across and see where does that fall. It falls between the 20 and this would be 25. It's somewhere between 20 and 25. So you could say any number between 20 and 25. It looks like it's maybe a little bit closer to 20. So I'm going to say $22. You could have any number that's between 20 and 25. 20 to 25 would be a good answer that you could put there. But anything that would be above 25 or below 20, that would be the wrong answer. Okay. So let's look at our next question, B. I'm going to erase all that there. Next one, B. In what year or years was the stock price $35 per share? Okay, so now we're looking for stock price. We're going to be looking on this side here, the $35 per share. Okay, so we've got 10, 20, 30, 40. So that means 35 falls here. Here's my 35. And we're going to look across to see our stock price at 35. Here's one and here's another. What year or years was the stock price $35 per share? I know one of them is 2010. But we have another one. What year was this point here? What year is that one? Go ahead and type that in the chat, or you can turn your microphone on. I see someone said 12, and awesome, perfect. If you drag it all the way down here, you can see it's 12. So we can say 2010 and 2012. Or you could just write 10 and 12. Next question. What is the relationship? This is where we can identify if it's positive, negative, or none. It helps if you kind of like circle all of your points here. And let's see, are they going from left to right? Upwards direction is positive, down is negative, and if they're all over the place, then it's none. So what kind of correlation is this one here? Positive, negative, or none for number 8? You can type it in the chat or you can turn your microphone on. Is it a positive, negative, or none? And it is negative. Perfect. It's going in the downwards direction from left to right. It's going down. So it's a negative correlation. The more years that we add on, the stock price just keeps going down, 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 down. Okay. I'm going to skip the next one. So if you wanted to practice that one on your own, you could. You could check your answers on Schoology. But let's go on to our next topic here, the line of best fit. Line of best fit, since we're kind of going over 2 different topics today. Okay, so for line of best fit, what is it? It is a line drawn on a scatter plot that is close to most of the data points, and it can be used to estimate your data. So we've got an example here. It says the graph below shows the relationship between minutes spent studying and the test scores for a math class. Which line best represents the data? Graph each line to justify your answer. I actually went through and did that for you. These are all in slope-intercept form. That's the y equals mx plus b. And just to kind of refresh your memory with how to graph slope-intercept form, y equals mx plus b, the first thing you want to do is plot b on the y-axis. And then you use your slope, m, which is rise over run, to draw your second point. Okay. So I went ahead and did that for you. I put them in different colors there so you can kind of visualize as well. But let's look at all of our lines here. Let's look at the first one, A. Okay, so A is our blue one, our blue line here. You can see it's pretty close to most of those points, but we're not going to say it's not an answer. We're not going to say it is an answer until we look at all of our choices there. But A could possibly be our line of best fit where it's close to most of those points. So we're going to keep that in the top of our mind. So maybe. And then let's look at B. B is the one that's in red. Okay, here's B. You can see the line B. It's like nowhere near our points. It's way off in the middle of nowhere. So we can definitely say that A is way closer than B. So we're gonna, we'll eliminate choice B, line B, because A is currently way closer than B. Let's look at our next one, C. That's the one in green. You can see there, that one's pretty close to all of our points. So that one's also a maybe. Let's look at our next one, D. That's our purple. Again, that one's off in the middle of nowhere. So that one is definitely not it. It's either going to be A or C. Okay, so we can eliminate D because that one's off in the middle of nowhere. You can even see here that B and D are just nowhere near our points. That's why we can just get rid of those completely. So we know it's either A or C. And we want to see which one's closest to most of our points. You can see A is just a little bit lower and C is a little bit higher than all of our, it's more of like in the middle there. So looking at these two choices here, C is going to be your better choice because it's closer to most of the points. You can see that A, it's close to a couple of points, but not necessarily all of them, where C is closer to most of them. So that's why C would be our correct or the best choice, the line of best fit here for our first example. Okay, so when you're doing this to find your line of best fit, first you want to draw a line that is close to most of the data points, and it should split the data. Like you can see here for our first example, that line choice C, it split the data in half. There's about equal number of points above and below that line. And then number 2, you find your slope between any 2 points on the line. You use your slope formula, which we'll go over that again. And then identify the y-intercept, the point where the line intersects the y-axis. And then you write your equation in slope-intercept form, y equals mx plus b. Okay. So we've got number 1, our first example. The graph below shows the ages and weights of 12 babies. So we've got our age and weight. I actually went ahead and drew my line of best fit. We know this is a positive correlation. It's going up. And when you draw your line, just like I said before, try and get your best to put it as close to the middle as possible. So we're all going to have some different answers here, but they should all pretty much look like this. If you were to draw your line like this red one, we can say, oh yeah, that is definitely wrong. Or even if you did your line like this red one here, that's definitely not anywhere near close to the blue one. But if your line was a little bit off like this, like that red line, that's okay. It's not the end of the world. It's probably not the best, but it's still pretty close to our answer there, because everyone's answers are going to be a little bit different when you do this. Okay, so I drew my line, and then I identified 2 points where my line is crossing there. I circled them for you so they kind of jump out. I did that ahead of time to save us some time to actually get the problem solving completed together. Over here on the left, I wrote down the slope formula to refresh your memory. M equals y2 minus y1 all over x2 minus x1. Okay, so that means we need 2 points. I circled them for you right here and here. And those 2 points are 0, 7, and let's see, 7, about 18. So your points, they're not going to be perfect since we don't see exactly where they're falling. It's in between. So sometimes your numbers might be a little bit off there as well. That's fine. Okay, so let's identify and find our slope. You can first label x1, y1, x2, y2, and we're going to plug it into our formula. We've got y2 minus y1, so first is 18 minus 7 all over x2, which is 7, minus 0. And then we can simplify our slope formula. First, let's do 18 minus 7 is 11 over 7 minus 0 is 7. So we've got our slope m, which is 11 over 7. And then we can identify b, our y-intercept. That's where our line crosses on the y-axis. I'm going to put a little red circle so you can see it here. This is the y-axis, and our point that crosses is here. We can see our y-intercept. It's crossing at, I covered over the numbers there, in between the 4 and 10, which ends up being 7. So we've got our two pieces of information. All we need to do now is plug it into our formula. Y equals mx plus b. This one's m and this one's b. So y equals 11 over 7x and then plus 7. And then that would be your answer there for A. And then we've got B. Estimate the weight of a baby that is 12 months old. Okay. So what we're going to do is we're going to take this 12. And this is pretty much saying like x equals 12. And we're going to use this formula, the one that we just created. We're going to take the 12, plug it in, and then solve. So I'm going to rewrite it here. We've got y equals 11 over 7. And then instead of x, I'm going to plug in my 12. And then plus 7. So then you can go ahead and solve it. 11 over 7 and then times 12 plus 7. You can use a calculator, that's fine. It's going to come out to about, so when I do the squiggly equal signs, that's an estimate, about 26 pounds. Okay, so once you plug that in your calculator, you solve with PEMDAS, you get your answer. It's going to be about 26 pounds. Okay, so for all of that whole section there, when you go to do this on your own, your answers are going to be a little bit different. That's fine. As long as your final answer is somewhere between, it's about 26 pounds, that's fine. If you were to get like 42 pounds, then first off, that's probably not really realistic, and it's not anywhere near close to 26. But if you got like a 27, 28, that's fine, or a little bit below, that's okay. Let's go on to our last page here. Yeah. Okay, so we've got number 2. It says, Beth started a new bank account. The graph below shows the monthly balance of the account in its first year. So we've got our months and account balance. First, we need to write the equation for the line of best fit. So we're going to use our slope formula, which was y2 minus y1 over x2 minus x1. Okay, so I went ahead and I drew the line of best fit. So your line's going to be somewhere in that general area. We know that if it looked like this, that would definitely not be it. Or if it looked like this, that would totally be wrong. So somewhere in between these points would be a good choice. And then let's pick out 2 points that are pretty good here. We're actually not, sorry, I wanted to skip this one. I wanted to go over, yeah, sorry, I wanted to go over this number 3 because it's a different kind of correlation. I apologize. That one there, I'm going to leave that one for you guys to try on your own because that one's similar to what we already did. I wanted to do a different one. I apologize. I looked at my notes wrong. Sorry, number 3. Number 3, it says a 10-inch tall candle is lit. The graph below shows its height after each hour. So you can see here, this one from left to right, it's going in the downwards direction. So it's a negative correlation. So that's why I chose this one to do together since it's a little bit different from what we've done already. And again, we're still doing the same thing, right? The equation for line of best fit, y2 minus y1 over x2 minus x1. Okay, so I drew my line on there, and then I identified 2 points. I circled them already here and here. My first point is 0, 10, and my next point is about 3, 9. And I'm going to label x1, y1, x2, y2, and then we can find our slope. Here's my formula, y2 minus y1. So I've got 9 minus 10 over x2 minus x1, 3 minus 0. And then we can simplify. 9 minus 10 is negative 1 over 3 minus 0 is 3. We've got part of our answer. We also need to figure out what is B. B is your y-intercept where your line crosses on the y-axis. That's this line here. Our line is crossing at this red dot, which it's right at the 10. So that means our y-intercept here is 10. We've got our two pieces of information. Plug it in this formula, y equals mx plus b. Oops. So here's my b. This goes into m. This goes into b. So it's really y equals, instead of m, I've got the negative 1 over 3. Here's my x. And then instead of b, I plug in the 10. So there's my formula. And then now they want us to estimate the height of a candle after 15 hours. This is very similar to saying x equals 15. So let's take this formula, rewrite it, plug it in. Instead of x, we're going to plug in a 15. So I've got y equals negative 1 over 3. Instead of x, I've got 15 and then plus 10. You would go ahead and solve. Using PEMDAS. And we can see here after doing it with PEMDAS, we end up with 5 inches. Okay, so that one comes out to an actual nice number. So you can just put in the exact answer. We wouldn't do the squiggly equals. It's an exact answer, 5 inches. Okay, and last question, I think. Yep, last question here. Says number 4. We're going to be kind of combining both our scatter plot with our line of best fit, putting it all together. It says the table to the left shows Nick's weight each week into his diet. Make a scatter plot of this data. So I've got time and the weight, because we have time and weight, plotted all of those points, and I drew my line of best fit. We know that this here is not a line of best fit, or this is also not a line of best fit. You want it to be as close to your points as possible. Somewhere in this little circle area would be acceptable for me if you were to draw your line. And let's identify our 2 points for A, because it wants us to write an equation. We've got our first point, we can say is 3, and then about 233. And our next one, 7, 225. Label x1, y1, x2, y2, and then we plug it into our formula that y2 minus y1 over x2 minus x1. So my y2 is 225 minus y1, which is 233, all over x2 is 7 minus x1 is 3. And then we can simplify. 225 minus 233, we get negative 8 over, and then 7 minus 3 is 4. We can actually simplify this one step further. You go ahead and divide negative 8 divided by 4, and we get negative 2. And then we also need B. B is our y-intercept, where the line crosses the y-axis. Whoops. Where it's crossing here. Looks like it's crossing about at this point here, which is 240. So let's say B equals 240. And then plug it into this formula, y equals mx plus b. M goes here, b goes here, so y equals, instead of m, we got negative 2. Here's the x, and then our plus b, but b is 240. So there's our formula. Then our last part here says estimate Nick's weight after 24 weeks. That's just like saying x equals 24. rewrite this formula, but instead of x, we're plugging in a 24. Oops. And we're solving with PEMDAS. And then once you do that, y equals -2 times 24 and then plus 240, you'll end up with 192 pounds. 192 pounds. That's how you can kind of estimate there. Once you get your formula, you can plug in anything. You can even figure out after 36 weeks what the weight will be. But realistically, it's not always going to end up keep going down. That's pretty much it for today. I skipped a couple of questions there, so you can try them on your own. So go ahead and practice those. If you need a little bit more support, or you can send me a message or ask me questions here. But if you feel good about this, you can go ahead and leave the chat, and then we'll have another meeting tomorrow, probably a short meeting since we're just doing EOC review. So if you're all good and you feel good about this, just make sure you say something in the chat before you leave so I can get your credit. So if you're leaving, bye guys.